Applications of Instrumentation Amplifier, Crazy Engineers. Introduction to Instrumentation Amplifier. In many industrial and consumer applications, the measurement and control of physical quantities are very important. They need precise measurement of physical quantities, like temperature, pressure, humidity, weight, etc. For example, the dairy plant needs measurement of temperature and humidity. A sugar factory needs measurement of flow, level and temperature of juice. Such type of measurements help the industries to have the production of quality products. Need for Instrumentation Amplifier. Transducer is a device which is used to convert one form of energy to another form of energy. The output of transducer will be low-level signals. This low-level signals cannot be used for next stage of system or for any applications. So, these low-level signals should be amplified using amplifier circuit, and then given to the next stage or for applications. The amplifier circuit used is nothing but the instrumentation amplifier. Instrumentation amplifier. The special amplifier, which is used for a low-level amplification, with high CMRR, high input impedance to avoid loading, low power consumption, is called instrumentation amplifier. Key features: high input impedance, low output impedance, high gain accuracy, high CMRR, high gain stability, with low temperature coefficient, low DC offset. There are specially designed op-amps, such as UA725 to meet the above stated requirements of a good instrumentation amplifier. Monolithic instrumentation amplifiers. Analog devices, AD521, AD524, AD620, AD624. National Semiconductor, LM363XX. Burr-Brown, INA 101, 104, 3626, 3629. Figure shows the instrumentation amplifier, using 3 operational amplifiers. In this circuit, the non-inverting amplifier is added to each of the basic difference amplifier inputs. The operational amplifier, A1 and A2 are non-inverting amplifiers, forming the input or first stage of the amplifier. It can be seen that the output state is a basic difference amplifier. If the output of operational amplifier, A1 equals V01 and A2 equals V02, then we can write V0 equals R2, divided by R1, into V02, minus V01. Let us find V01, and V02, from the first stage, in terms of V1, V2, R1-, R2- and Rg. Summary: from stage 1, V02 minus V01 equal to V2 minus V1 divided by Rg and 2R plus Rg. Stage 1 output, given to difference amplifier. Difference amplifier, output equation is V0 is equal to R2 divided by R1 into V02 minus V01. Substituting V02 minus V01 from stage 1 in above equation, we get V0 equal to R2 divided by R1 into 2R plus Rg, divided by Rg, into V2 minus V1. Rearranging, we get V0 equal to R2 divided by R1 into 1 plus 2R divided by Rg, into V2 minus V1. Applications of Instrumentation Amplifier. The instrumentation amplifier, along with the transducer bridge, can be used in many practical applications. Normally, bridge is formed by the use of resistors. So, it is normal as resistive type transducer. In these resistive type transducers, the resistance changes as a function of some physical quantity. Thermistors, photoconductive cells, and strain gauges are some of the most commonly used resistive type transducers. Application 1. Temperature indicator. Instrumentation amplifier, with transducer bridge, can be used as a temperature indicator, as shown in figure. A simple and inexpensive temperature indicator circuit can be constructed by using a thermistor in the bridge circuit. Thermistors are normally semiconductors that behaves as resistors, usually with a negative temperature coefficient. Negative temperature coefficient means, as the temperature of the thermistor increases, its resistance decreases. Thermistors with a high temperature coefficient of resistance are more sensitive to temperature change, and are well suited for temperature measurement and control. Consider a bridge as balanced at a desired reference condition 25 degrees Celsius. As the temperature doesn't varies from its reference value, 25 degrees Celsius, the resistance of the thermistor doesn't changes, and the bridge will be in balanced condition. As the temperature varies from its reference value, 25 degrees Celsius, the resistance of the thermistor changes and the bridge becomes unbalanced. This unbalanced bridge in turn produces the meter movement. The meter movement is dependent on the amount of imbalance in the bridge. That is, the change in resistance, delta R, in the value of the thermistor resistance. The meter connected at the output is calibrated to reference temperature, corresponding to the reference condition. The meter can be calibrated to indicate the desired temperature range by selecting the appropriate gain of the amplifier. As temperature changes, amplifier output changes, and so meter movement occurs. Application 2. Temperature controller. A simple and inexpensive temperature controller circuit can be constructed by using a thermistor in the bridge circuit, and by replacing a meter with a relay in the temperature indicator circuit. The bridge is set balanced for a particular reference temperature. For any change in this temperature, the instrumentation amplifier produces the output voltage. The output of the instrumentation amplifier drives a relay that controls the current in the heat generating circuit. Also, the relay unit controls the on-off state of the heating unit to control the temperature. A properly designed circuit should energize a relay when the temperature of the thermistor drops below a desired value, causing the heating unit to turn on. Application 3. Light intensity meter. If a transducer is replaced with a photocell, called light intensity meter. Photocell or photoconductive cell belongs to the family of photosensitive devices whose resistance varies with an incident radiant energy or with an incident light. As the intensity of incident light increases, the resistance of the cell decreases. The resistance of the photoconductive cell in darkness is typically on the order of 100 kΩ. The bridge can be balanced for darkness condition. When light falls on the photocell, its resistance changes and produces unbalanced bridge condition. This produces the output. The meter can be calibrated in terms of lux to measure the light intensity. Generally, the intensity of light is expressed in meter candlux, lux. The light intensity meter using an instrumentation bridge amplifier is more accurate and stable than single input inverting or non-inverting amplifiers. Because the common mode noise voltages are effectively rejected by the differential configurations. Analog weight scale, load cell weight measurement. A simple and inexpensive analog weight scale may be constructed by connecting a strain gauge in all the four arms of the bridge of an instrumentation amplifier. Strain gauge is one of the important resistive transducer whose resistance changes due to elongation or compression when an external stress is applied. The elements are mounted on the base of the weight platform. When an external force or weight is applied to the platform, one pair of elements in the opposite arms elongates, whereas the other pair of elements in the opposite arms compresses. When the weight is placed on the platform, RT1 and RT3 both decrease in resistance, and RT2 and RT4 both increase in resistance, or vice versa. When no weight is placed on the platform, the bridge is balanced. In this condition, RT1 equals RT2 equals RT3 equals RT4 equals R, and also the output voltage of the weight scale is 0. When the weight is placed on the platform, the bridge becomes unbalanced. Assuming that RT1 and RT3 decrease in resistance, and RT2 and RT4 increase in resistance by the same number of ohms. The change in resistance is denoted by del R. The output equation of load cell weight measurement is derived as V0 equals R2 divided by R1 into del R, VDC divided by R, as shown. The output voltage is proportional to the change in the resistance, also it depends on the applied DC voltage. The gain of the amplifier can be selected according to the sensitivity of the strain gauge and the full-scale deflection requirements of the meter. The meter connected at the output can be calibrated, in terms of kilograms. Thank you for subscribing to Crazy Engineers.